The very first step in any sensor testing routine is to perform a visual inspection of the sensor in question. This also includes its wiring and connector portion. In our example, we'll be testing a magnetic sensor, which is evident from the two terminals at the connector side. Magnetic sensors always employ two electrical terminals and produce a rounded wave, also called a sine wave, as opposed to a DC square wave. Square waves are produced by Hall effect, magnetoresistive, and optical sensors. Step 1 is to start by connecting the oscilloscope or digital multimeter to the magnetic sensor's two terminals. Magnetic sensors are usually not polarity sensitive, so it is irrelevant on how you connect the oscilloscope or graphing multimeter. Make sure that the oscilloscope or graphing multimeter is not internally grounding one of the leads. In many cases, this non-polarity condition of magnetic sensor circuits also mean that the magnetic sensor ground is not the same as battery or chassis ground, even if the sensor is internally grounded by the ECM. Remember, it may not be necessary to observe polarity when testing a magnetic speed position sensor. Simply make sure that your equipment is not internally grounding one of the leads. The output of a magnetic sensor is always going to be a sine wave, which is always rounded at the edges. Also, due to the alternating current producing nature of magnetic sensors, always set your scope to AC, or alternating current. Since we are measuring an alternating current cycle, set your zero line on the scope to halfway of the graticular screen. This will let you measure both sides of the cycle. Step 2, set your time base to a value that allows you to measure the signal at idle. This is usually around 2 milliseconds. A higher time base setting may be needed to pack more cycles on the screen and therefore be able to catch a possible signal glitch. This could be as much as 100 to 500 milliseconds. After starting the engine, the magnetic sensor sine wave should immediately show up on the screen. Verify the two characteristics of any repeating waveform, which is amplitude and frequency. As a rule of thumb, a minimum of 2 volts peak-to-peak is needed for signal recognition, and the frequency should correspond to the speed of engine rotation.